At 9:47 a.m. on October 14, 1943, Staff Sergeant Thomas Harlan stood at his waist gun position aboard the B-17 Defiant, watching six Focke-Wulf 190s orbit his formation at 2,000 yards, knowing they were too far away to shoot and too close to ignore. 24 years old, 18 months in theatre, 0 confirmed kills at extreme range. The German fighters circled like wolves around wounded prey. They stayed just beyond effective American gunnery range, close enough to intimidate, far enough to be safe. The B-17 seconds couldn't do anything except watch and wait for the attack they knew was coming. Harlan's twin 50 caliber machine guns could throw rounds 2,000 yards. The bullets would travel that distance. Physics didn't prevent it, but hitting a maneuvering fighter at that range required calculating lead, deflection, bullet drop, and closing speed. The standard ring-and-bead gun sight couldn't do those calculations. Human eyeballing couldn't do it. Army Air Force doctrine said, don't even try. Official maximum engagement range, 600 yards. Official recommendation, hold fire until fighters commit to attack runs. Official reasoning, ammunition conservation. Wasting rounds on targets you can't hit means being dry when targets you can hit arrive. The doctrine made sense on paper. It was killing men in the air. The altitude was 25,000 feet. Temperature minus 40 degrees Fahrenheit, despite the heated flight suit. The 4 Wright Cyclone engines vibrated through the aircraft frame. Harlan could smell cordite from earlier flak bursts, could taste the rubber from his oxygen mask, could feel the cold seeping through his gloves as his hands gripped the gun mount. The 6 Focke-Wulf 190s completed another orbit. Professional, coordinated, patient. They weren't rushing. They had time. They were waiting for Defiant to fall further behind the formation, waiting for the gap to widen, waiting until the bomber was completely isolated and defenseless. Then they'd attack from multiple angles simultaneously. By the time they closed to 600 yards where American doctrine said to open fire, they'd already chosen their vectors, already built momentum, already positioned for kills. Harlan had watched it happen 17 times in 18 months, watched German fighters orbit safely, watched bomber gunners fire ineffective bursts at extreme range, watched ammunition run dry, watched fighters close in and methodically destroy defenseless bombers. The problem wasn't new. The problem had been killing American crews since the 8th Air Force began daylight bombing operations over Europe. Between June and September 1943, the 8th Air Force lost 142 B-17 seconds to German fighter attacks. Not from flak, not from mechanical failure, from fighters that exploited a critical vulnerability in American defensive fire. The vulnerability was simple. German fighters had learned to orbit at 1,800 to 2,200 yards, just beyond the effective range of standard American gun sights. At that distance, ring and bead sights became almost useless. Gunners could see the fighters circling, could see them coordinating, but calculating proper lead and deflection at extreme range was guesswork. By the time fighters closed to 800 yards where American gunners could engage with reasonable accuracy, the Germans had already analyzed the bomber's formation position, already identified weak spots, already coordinated their attack vectors. American doctrine said, hold fire until 600 yards. Conserve ammunition. Engage only when certain of hits. The doctrine assumed fighters would approach individually or in pairs. Assumed gunners would have clear shots at committed targets. Assumed formations would stay together and provide overlapping defensive fire. Reality was different. Bombers separated from formations, constantly. Battle damage, mechanical failure, navigation errors, engine problems, oxygen system malfunctions. Any of a dozen reasons why a bomber might fall behind the protective formation, and when bombers separated, they died. In September 1943 alone, 47 B-17 seconds separated from formations over Germany. 29 never made it home. 62% loss rate for isolated aircraft. The mathematics was brutal and clear. Get separated. Get killed. The average survival time for an isolated bomber was 11 minutes. 11 minutes from first fighter contact to complete destruction. German fighters would appear within minutes of separation. They'd orbit at extreme range, 1,700 to 2,200 yards, just beyond American gun range. They'd coordinate attack vectors while bomber crews watched helplessly. Then they'd attack from multiple directions simultaneously. Most isolated bombers couldn't defend against coordinated multi-axis attacks. Gunners would engage targets from one direction while fighters attacked from another. By the time gunners traversed their weapons, the attacking fighters had already made their firing passes. Most bombers went down burning, some exploded, a few managed crash landings in occupied territory. Crews became prisoners if they survived the crash. 142 bombers lost in September. Average crew, 10 men. That was 1,420 crew members dead, missing, or captured in 1 month. 47 bombers per day on average. The attrition rate was unsustainable. The 8th Air Force called it acceptable losses. Command said bomber formations provided overlapping defensive fire. Said fighters couldn't orbit formations at extreme range because formation gunners would concentrate fire and drive them off. Said isolated bombers were statistical anomalies. But Harlan knew the statistics told a different story. The numbers didn't lie. Isolated bombers died at catastrophic rates, and the current defensive doctrine provided no solution. The problem wasn't the guns. Browning 50 caliber machine guns were devastating weapons. 13mm bullets, muzzle velocity 2,900 feet per second, 700 rounds per minute cyclic rate. Effective range against maneuvering aircraft, 600 yards according to the manual. But that number assumed standard ring-and-bead sights. Assumed gunners eyeballing deflection and lead. The guns could shoot farther, much farther. Maximum range exceeded 5,000 yards. The bullets would travel that distance before gravity pulled them to Earth. The limitation wasn't the weapon. The limitation was the sight. The ring-and-bead sight worked adequately at 600 yards. A fighter at that range filled enough of the sight picture that gunners could judge speed and deflection reasonably well. But at 2,000 yards, the fighter was too small. The required lead was too great. The bullet drop was too significant. Gunners who tried to engage at extreme range usually missed by hundreds of feet. Tracers would arc through empty sky, nowhere near the target. German pilots knew this. They'd learned to exploit it. They could orbit American bombers at 2,000 yards with near impunity. The Americans couldn't touch them. Harlan understood the geometry better than most gunners. Before the war, he'd worked as a surveyor for Great Northern Railway in Montana. His job involved calculating angles, distances, and trajectories for railroad construction through mountain terrain. He'd spent 3 years measuring trajectories, accounting for elevation changes, calculating precise positions for track that had to align perfectly over miles of wilderness. The mathematics for ballistic trajectories wasn't that different from the mathematics for railroad grades. Distance, angle, drop rate, correction factors. Surveying required understanding how projectiles moved through 3-dimensional space. When you dropped equipment from a moving rail car on a mountain grade, you had to calculate where it would land. Moving platform, gravity, wind, terrain. He'd done those calculations hundreds of times with slide rules and reference tables. The mathematics wasn't simple, but it wasn't impossible either. When he joined the Army Air Force in January 1942, the recruiter tried to assign him to bombardier training. Bombardiers got officer commissions. Bombardiers calculated trajectories for bombs. Harlan's surveying experience made him qualified. He declined. Bombardiers came from college graduates and men with family connections. Harlan was neither. He'd learned surveying through correspondence courses and 5 years of fieldwork. He knew trigonometry, ballistics, and practical engineering better than most college graduates, but he didn't have the credentials the Army valued, so he became a gunner. Gunnery school at Fort Myers, Florida. 6 weeks of training. The instructors taught the basics: how to load the guns, how to clear jams, how to estimate range, How to aim using the ring-and-bead sight. Simple point-and-shoot doctrine. If the enemy fighter fits inside the ring, you're in range. Lead the target by estimating its speed. Fire short bursts. Conserve ammunition. The training was adequate for 600-yard engagements against fighters committed to attack runs. At that range, fighters were close enough that the ring-and-bead sight worked reasonably well. Gunners could see the target clearly, could judge speed and deflection, could put rounds on target with practice. But at 2,000 yards, the ring-and-bead sight became worthless. The target was too small. The required lead was too extreme. The bullet drop was too significant. Gunners couldn't compensate for variables they couldn't calculate. Harlan had been thinking about this problem for months, thinking about it between missions, thinking about it during long hours over Germany watching fighters orbit safely, thinking about it at night in his bunk while the smell of aviation fuel and high-altitude cold still clung to his flight suit. The problem was calculable. He knew it was calculable because he'd calculated similar problems for 3 years in Montana. Moving platform, moving target, gravity affecting the projectile, wind drift. The mathematics was documented, known, solved. 50 caliber rounds had known ballistic characteristics. Muzzle velocity, 2,900 feet per second. Bullet weight, 710 grains. Ballistic coefficient documented in Army manuals. At 2,000 yards, the bullet would drop approximately 120 feet from bore line. Flight time, approximately 2.4 seconds. During that flight time, a fighter traveling at 300 miles per hour would move 1,056 feet. The required lead wasn't guesswork, it was mathematics. Calculate the variables, apply the formula, get the answer. The standard gun sight couldn't do that mathematics. The ring-and-bead sight was mechanical, simple. It worked for short-range shooting where gunners could estimate lead visually, but it couldn't calculate complex trajectories at extreme range. A custom sight grid could. Harlan had started sketching designs in July 1943, used his surveying notebooks during off-duty hours, calculated drop rates at 500-yard intervals from 1,000 to 2,500 yards, calculated required lead for targets at various speeds and angles. The mathematics took 3 weeks. He worked on calculations during off-duty hours, used ballistic tables from the Bombardier's manual that he'd borrowed from Lieutenant Frank Wilson, cross-referenced with his own surveying references from correspondence courses he'd saved, checked and rechecked the numbers. The calculations had to be perfect. 1 degree of error at 2,000 yards meant missing by hundreds of feet. The grid lines had to be positioned with absolute precision. The reference points had to correspond exactly to calculated trajectories. By August, he had a complete grid design, drawn to scale on graph paper, 12 inches by 8 inches. 12 reference lines for range estimation at 500-yard intervals. 24 aiming points for targets at various speeds and angles. Each line positioned to 1/16-inch tolerance. The design looked professional. Looked like something that should have come from an engineering department. But it came from a surveyor's notebook and 3 weeks of ballistic calculations done by flashlight in a maintenance tent. The next problem was construction. The grid needed to overlay his gun sight without blocking his view. Needed to be transparent enough to see through but marked clearly enough to use in combat. Needed to be precise enough for 2,000-yard shots. Needed to be durable enough to survive combat vibration and temperature extremes at 25,000 feet. He needed materials. Plexiglass for the transparent overlay, wire for the grid lines, precision tools for cutting and marking, adhesive that would hold at altitude, and he needed to acquire all of it without explaining why he was building an unauthorized modification to a flight control system, because that's what this was, an unauthorized modification, a violation of Army Air Force maintenance regulations, a change to fire control systems that field mechanics had no authority to make. If command found out before he could prove it worked, he'd face court-martial, possible dishonorable discharge, maybe prison time, but doing nothing meant watching more bombers die, watching more crews burn. watching fighters orbit safely at 2,000 yards while American gunners sat helpless. Harlan had watched 17 bombers die that way. 17 bombers times 10 crew members equals 170 men, 170 funerals, 170 families receiving telegrams. The mathematics of death was as precise as the mathematics of ballistics. And Harlan was done watching the numbers climb. He found the materials in late August 1943. A B-17 called Lucky Strike took flak damage over Bremen and crash-landed at their base with the nose section destroyed. The aircraft hit the runway at 140 miles per hour, with landing gear partially collapsed. The pilots walked away. The bombardier walked away. The navigator broke his arm. The nose section crumpled like paper. The salvage crew descended on Lucky Strike within hours, pulling usable parts, stripping ammunition, recovering instruments. The plexiglass from the bombardier's station came out in sections. Some pieces shattered. Some remained intact. The crew chief sorted the salvage into bins, undamaged parts for reuse, damaged parts for scrap. Harlan approached Technical Sergeant Frank Morrison in the salvage yard on August 24th. Morrison was 41 years old. Career: enlisted. 23 years in the Army. He'd been maintaining aircraft since biplanes and fabric wings. He knew regulations. He followed procedures. He didn't tolerate unauthorized modifications. "I need a piece of plexiglass," Harlan said. Morrison looked up from his clipboard. "What for?" "Protective windscreen for my gun position. Wind at altitude is brutal. Thought I could mount a deflector." Morrison considered this. Wind protection wasn't a bad idea. Some gunners had fabricated windscreens from salvaged canopy sections. Unofficial but practical. Not technically a flight control modification, just crew comfort. "Take a section from the nose pieces," Morrison said. "Nothing bigger than 2 feet square. And don't screw up the gun mount installing it." "Yes, Sergeant." Harlan selected an 18-inch square section. Clear plexiglass, 1/4 inch thick, perfect for his needs. He carried it back to his bunk and hid it under his footlocker. One material acquired, no questions asked. Piano wire was harder. He needed high-tensile steel wire for the grid lines, thin enough to not obscure vision, strong enough to maintain position under vibration. Aircraft control cables used the right wire, but requesting control cable without a work order would raise questions. The solution appeared on September 2nd. B-17 Hell's Angel ground-looped during landing after the left main gear collapsed. The aircraft slewed off the runway. The left wing dug into the dirt. The number 1 and number 2 engines tore loose. The fuselage buckled at the radio compartment. Total loss. The crew evacuated without serious injury. The aircraft was written off, sent to salvage. The wreck sat on the taxiway for 3 days before the salvage crew began stripping it. Harlan watched them work, watched them pull instruments, watched them drain fuel, watched them begin removing control cables from the wing and tail sections. On September 5th, after 2,300 hours, Harlan walked to the wreck with wire cutters. The salvage area was dark, quiet. Most of the crew was asleep. He climbed into Hell's Angel's tail section through the torn fuselage, found the rudder trim control cables, cut a 6-foot section of piano wire from the trim system, cleaned up the loose ends, climbed out, walked back to his bunk. 2 materials acquired, both from salvaged aircraft, both technically unauthorized, but not obviously unauthorized. Just a mechanic pulling parts from wrecks, standard practice in a combat zone where spare parts were scarce. He had what he needed now: plexiglass and piano wire. The raw materials for a sight grid that would either save lives or end his military career. Construction began on September 7th. Harlan worked alone in the maintenance hangar after 2,300 hours. The hangar was a Quonset hut. Curved corrugated metal walls, concrete floor, overhead lights that buzzed with electrical interference. The smell of hydraulic fluid and engine oil hung in the air. He worked at a small bench in the corner, set up his tools. Plexiglass sheet, piano wire, diamond-tipped scribe he'd borrowed from the instrument shop, aircraft epoxy, ruler, compass, protractor. His surveying notebooks with the calculated grid specifications. First step. Cut the plexiglass to exact dimensions, 12 inches by 8 inches. He measured twice, cut once. Used a fine-toothed hacksaw. The plexiglass cut cleanly, but the edges needed smoothing. He used progressively finer sandpaper until the edges were uniform. Second step. Mark the grid lines. This required absolute precision. Each line had to be positioned within 1/16 of an inch of the calculated position. Any deviation would throw off the aim points at 2,000 yards. A 1/16 inch error at the site translated to roughly 80 feet of error at extreme range. He used the diamond-tipped scribe to score lines into the plexiglass surface, 12 horizontal reference lines for range estimation, each line corresponding to 500-yard intervals from 1,000 to 2,500 yards. The lines had to be perfectly parallel, perfectly spaced. His hands cramped from the precision work. The scribe required constant pressure to cut through the plexiglass surface without cracking it. Too much pressure, and the material would fracture. Too little, and the line would be too shallow to see in combat. He worked for 4 hours the first night, completed 8 of the 12 reference lines. His eyes strained from the close work in dim hangar lighting. His fingers ached. His back hurt from hunching over the bench. But the lines were perfect, parallel, evenly spaced, exactly matching his calculations. Second night, September 8th. He completed the remaining 4 reference lines. Then began the vertical lines for the aiming points. 24 vertical marks, positioned at calculated intervals along each horizontal reference line. Each mark corresponded to required lead for targets at specific speeds and angles. A fighter at 2,000 yards traveling 300 miles per hour perpendicular to his line of fire required different lead than a fighter closing head-on at the same range. The vertical marks accounted for these variations, gave him reference points for different target geometries. The vertical marks were harder than the horizontal lines, shorter, more numerous. Each one had to be positioned precisely relative to the horizontal lines. He measured, marked, measured again, scribed the line, checked the position. His hands were shaking by midnight from fatigue and concentration. He forced himself to slow down. Precision mattered more than speed. One misplaced mark would compromise the entire grid. He completed 16 vertical marks before his eyes refused to focus anymore. Quit for the night, hid the partial grid under a workbench, went to his bunk. Third night, September 9th. He completed the remaining 8 vertical marks. Then began the most critical step: mounting the piano wire. The piano wire would make the grid lines visible in combat. The scribed lines in the plexiglass were visible up close, but would be nearly impossible to see at arm's length with eyes focused on distant targets. The wire provided high-contrast reference lines that would remain visible regardless of background or lighting conditions. He cut the piano wire into precise lengths. Each piece had to span the width of the plexiglass and align exactly with the scribed lines. He used aircraft epoxy to bond the wire to the plexiglass surface, applied tiny beads of epoxy along the scribed lines, positioned the wire, held it in place while the epoxy set. The epoxy had a 10-minute working time before it began to cure. He could only mount 3 wires per epoxy batch. That meant mixing multiple small batches, waiting for each to cure partially, moving to the next wire. His fingers were sticky with epoxy. He cut his right thumb twice on the piano wire. The wire was sharp, designed to withstand high tension in aircraft control systems. It drew blood easily. He wrapped his thumb in a handkerchief and kept working. By 0200 hours on September 10th, all 12 horizontal wires were mounted. By 0330, all 24 vertical position marks were installed. The grid was complete. He held it up to the overhead lights, examined it from different angles. The piano wire created crisp black lines against the transparent plexiglass. The reference marks were clearly visible. The spacing was precise. The construction was clean and professional. It looked like factory equipment. like something that should have come with the aircraft. Not like something a sergeant had built in secret over 3 nights from salvaged materials. The finished sight grid measured 12 inches by 8 inches, weighed approximately 8 ounces, would mount directly in front of his existing ring and bead sight. The grid lines showed range estimation marks at 500-yard intervals. The vertical marks showed aiming points for various target speeds and angles. At 2,000 yards, if he aligned a circling fighter on the correct grid intersection and fired, the rounds should arrive where the fighter would be in 2.4 seconds. Should, theoretically, based on calculations he'd done in a notebook with salvaged ballistic data. He'd never tested it. Couldn't test it without revealing the unauthorized modification. Couldn't reveal it without facing court-martial. He cleaned up the workspace, disposed of plexiglass scraps, returned the borrowed scribe to the instrument shop, hid the completed sight grid in his footlocker under his spare uniforms, went to his bunk at 0400 hours, slept for 2 hours before reveille. On October 1st, 1943, Harlan installed the sight grid on his gun mount. He worked during the pre-dawn darkness before the crew chiefs began their morning inspections. The installation took 40 minutes. First, he loosened the mount bolts holding his existing ring and bead sight assembly. Not removing the sight, just creating enough clearance to position the grid behind it. The grid would overlay the ring and bead sight, adding calculated reference points without completely replacing the standard aiming system. He positioned the grid carefully. The horizontal reference lines had to align perfectly with his bore axis. Misalignment would make the calculated aim points worthless. He used a plumb line and level to ensure proper orientation, checked the alignment 3 times. Once satisfied with position, he secured the grid using additional mounting brackets he'd fabricated from aluminum stock. The brackets attached to existing mount points. Didn't require drilling new holes or modifying the primary gun mount structure. Technically, this made the installation less permanent, less obviously a modification. He tightened everything down, checked that the guns could still traverse and elevate properly. The grid didn't interfere with gun movement, didn't block critical sight lines, didn't add significant weight to the mount. From outside the aircraft, the modification was invisible. The grid was positioned behind the gun mount housing. Unless someone looked directly through the sight picture from the gunner's position, they wouldn't see it. He cleaned up metal shavings from the drilling, wiped away excess grease from the mount bolts, made sure everything looked standard. Then he waited for Morrison's pre-flight inspection. Morrison arrived at 0630, conducted his walk-around inspection of Defiant, checked control surfaces, checked tires, checked engine cowlings, entered through the waist door, inspected each gun position. He stopped at Harlan's position, checked the ammunition feed, checked the guns cycled properly, looked at the mount, didn't look through the sight picture, marked his inspection checklist and moved to the next position. The modification passed inspection. Morrison didn't notice anything unusual. The sight grid remained hidden in plain sight. Harlan flew 3 missions with the grid installed, October 2nd, 4th, and 7th. All 3 missions involved formation bombing runs to targets in France and Western Germany. Heavy flak but limited fighter contact. The few fighters that appeared stayed at altitude or attacked other formations. None approached Defiant at extreme range. Harlan never fired a shot beyond 600 yards. Never had opportunity to test whether the grid worked. Never proved whether 3 nights of construction and calculations would translate to combat effectiveness. By October 13th, he started wondering if he'd wasted 3 weeks of work on a modification he'd never use. Started thinking, maybe command was right. Maybe extreme-range gunnery was just ammunition waste. Maybe the mathematics was sound, but the reality was impossible. Then came the mission briefing for October 14th. The briefing room was crowded. Pilots, co-pilots, navigators, bombardiers, gunners, radio operators. 58 crew members for 6 B-17 seconds from their squadron. The intelligence officer stood at the front next to a covered map board. Captain James Whittaker sat in the front row. 53 missions completed, 28 years old, but looked 40. Dark circles under his eyes from too many missions and too little sleep. He commanded Defiant. He'd kept his crew alive through 18 months of combat. His survival record was better than most. The intelligence officer pulled the cover off the map board. Red yarn stretched from their base in England to a target deep in Germany. The yarn passed over occupied France, across the Rhine, into the industrial heart of Germany. "Gentlemen, tomorrow's target is Schweinfurt," the intelligence officer said. "Ball-bearing factories, primary industrial target. 291 B-17 seconds assigned." Murmurs through the briefing room. Everyone knew Schweinfurt. Defended by hundreds of flak batteries. Protected by multiple German fighter wings. 600 miles round trip. Beyond the range of fighter escort for most of the mission. This will be the deepest penetration into Germany without continuous fighter escort, the intelligence officer continued. Expect heavy coordinated fighter opposition. W-190s and Bf-109s from multiple fighter groups. He paused. Let that information settle. Estimated losses are significant. That was military language for catastrophic. Significant losses meant they expected dozens of bombers wouldn't come back. Hundreds of crew members killed or captured. But the mission was necessary. The ball-bearing factories at Schweinfurt produced 67% of Germany's ball bearings. Destroy the factories and German war production would grind to a halt. Literally. The briefing continued. Route details. Timing. Bombing altitudes. Rally points. Emergency procedures. The crews took notes. Asked questions. Prepared mentally for what they all knew would be a brutal mission. Harlan sat in the back row and thought about his sight grid. Thought about the 3 nights of construction. Thought about the mathematics. Thought about whether tomorrow would be the day he'd finally test it. He didn't know that October 14th, 1943, would become known as Black Thursday. Didn't know the 8th Air Force would lose 60 bombers that day. 600 men killed or missing. Didn't know it would be the costliest daylight bombing raid of the war. He only knew that Defiant would be flying into the most heavily defended airspace in Europe, and that German fighters would be waiting. And that his untested sight grid would either work or Defiant would join the casualty statistics like 142 bombers had in September. The briefing ended at 2100 hours. The crews dispersed. Some wrote letters home, some cleaned weapons, some tried to sleep. Harlan went to the flight line, stood next to Defiant in the darkness, looked at his gun position, at the sight grid hidden behind the mount housing. 3 nights of work. 18 months of watching bombers die, all coming down to tomorrow's mission. He didn't pray. Didn't believe in prayer. He believed in mathematics, in ballistics, in calculated trajectories. Tomorrow he'd find out if belief was enough. Defiant took off at 07:15 on October 14th, 1943, engines roaring at full power. The heavily loaded bomber used every foot of the runway. 50,000 pounds of aircraft, fuel, bombs, and ammunition, lifted off at 100 to 32 miles per hour. Climbed slowly into the morning sky over England. Formation assembly took 90 minutes, 291 B-17 seconds from multiple bomber groups circling over East Anglia, finding their positions, establishing the combat box formation. Stacked elements providing overlapping defensive fire. The theory was sound. Fighters couldn't penetrate properly coordinated formations without taking devastating losses. The theory worked when formations stayed together. At 08:30, the massive formation turned east, crossed the English Channel, entered German-occupied France at 12,000 feet, climbed to bombing altitude, 25,000 feet. The air was thin, cold. Every breath through the oxygen mask required effort. German radar tracked them from the moment they crossed the coast. Luftwaffe fighter controllers scrambled units across western Germany. W-190s, Bf-109s. Dozens of fighters moving into position, setting up ambushes along the bomber route. The first flak appeared at 09:15 over occupied Belgium. black puffs of smoke at 23,000 feet. The gunners on the ground were good, experienced. The flak bursts walked through the formation. Most shells exploded harmlessly between aircraft. Some got close enough to rattle airframes with concussion. A few connected. Defiant took the first hit at 0918. Flak shell exploded 400 feet below and to the right. Shrapnel punched through the right wing. 3 holes, nothing critical. The wing kept flying. The fuel tanks didn't leak. Acceptable damage. The second hit came at 0923. Closer. Flak burst 200 feet directly below. Shrapnel ripped through the belly. Cut hydraulic lines. Punctured the bomb bay. One fragment hit number 3 engine's oil cooler. Oil pressure began dropping immediately. The flight engineer called it over the intercom. Number 3 losing oil pressure, down to 40 pounds, dropping. Captain Whitaker's response was calm, professional. Watch it. If it drops below 30, we feather. Oil pressure continued falling. 35 pounds. 32 pounds. The engine was hemorrhaging oil from the damaged cooler. Without oil, the engine would seize. A seized engine could catch fire. Fire could spread to the fuel tanks in the wing. That would end with an explosion that killed everyone aboard. At 0927, oil pressure hit 28 pounds. Feather number 3, Whitaker ordered. The flight engineer pulled the feather button. The propeller blades rotated to knife edge. Stopped windmilling. The engine shut down. Number 3 went dead. Defiant was now flying on 3 engines. The bomber could maintain altitude on 3 engines, could maintain formation speed, but only barely. Any additional damage would be catastrophic. The formation continued toward Schweinfurt. The bombers maintained 180 miles per hour. Defiant on 3 engines managed 165. The gap started opening. Slowly at first, then faster as the formation's lead elements pulled away. At 0947, 6 Fokker-Wulf 190s appeared at 2,000 yards. They'd been orbiting at altitude, watching the formation, waiting for damaged bombers to fall behind. They saw Defiant struggling on 3 engines, saw the gap opening between Defiant and the formation. They moved into attack position. Technical Sergeant Frank Morrison's voice crackled over the intercom from the top turret. Fighters at 6 o'clock high, 2,000 yards, 6 bandits. Ferv 190s. Whitaker responded immediately. All gunners stand by. Hold fire until they commit. Standard doctrine. Wait for fighters to close. Conserve ammunition. Engage at 600 yards maximum range. But Harlan was staring at 6 fighters orbiting at 2,000 yards. Watching them coordinate. Watching them position. They weren't going to attack yet. They were waiting. Waiting for Defiant to fall further behind. Waiting for the formation to get completely out of range. Waiting until Defiant was isolated and defenseless. Then they'd attack from multiple directions. By the time they closed to 600 yards, they'd have chosen their vectors, built momentum, positioned for kills. Standard German, tactic, proven, effective. Killed 142 bombers in September. Harlan's hands moved to his gun grips, his eye aligned with the sight grid for the first time in actual combat, the plexiglass overlay with its piano wire grid lines. 12 horizontal reference marks for range, 24 vertical marks for lead calculation, 3 nights of construction, 18 months of watching the doctrine fail. The lead Fu 190 completed another orbit, crossed the 2,000-yard reference line on Harlan's grid. The fighter was circling, not attacking yet, just maintaining position, watching, waiting. Harlan calculated the geometry. The fighter was orbiting at constant distance but changing bearing. Orbital flight path. Curved trajectory. Not the straight-line movement he'd calculated for. The railroad surveying mathematics assumed linear motion. This was rotational. He adjusted mentally. Led the fighter by 3 aircraft lengths based on his grid's calculated aim point. His thumb moved to the trigger. Morrison's voice came over the intercom. Harlan, do not fire. That's 2,000 yards. You'll waste ammunition. Harlan pressed the trigger anyway. 4-round burst. The twin 50s hammered. Recoil shook the gun mount. Brass casings ejected into the slipstream. The smell of cordite filled the waist compartment. Tracers arced away from the aircraft, climbed, dropped, traveled 2,000 yards in approximately 2.4 seconds according to his calculations, and missed by 300 feet. The tracers passed behind the Fu-190. His lead calculation was wrong. The fighter's orbital path created different geometry than he'd calculated for. The curved trajectory required different compensation than straight-line interception. But the Fu-190 pilot saw the tracers, saw rounds reaching toward him at ranges American bombers shouldn't be able to achieve. The fighter broke its orbit pattern momentarily, climbed 500 feet, then resumed circling at 2,500 yards. Morrison's voice exploded over the intercom. "Waste! What the hell are you shooting at? Cease fire! You're burning ammo at impossible ranges." Harlan didn't respond. He tracked the W-190 through another orbit, analyzed his miss. The fighter was moving in a circle. The required lead wasn't just forward along the flight path. It had to account for the rotational movement. The aim point needed to be further ahead, compensating not just for closure time but for the fighter's angular velocity around the orbit. He picked a new aim point, led by 4 aircraft lengths instead of 3, pressed the trigger. 6-round burst. Tracers arced away again. This time they passed 200 feet in front of the Fu-190. Closer. Still a miss. But much closer. The fighter pilot definitely noticed. All 6 W-190s broke formation, climbed to 3,000 yards, outside Harlan's calculated grid range. They'd seen 2 bursts reaching toward them. Seen tracers at ranges that violated every tactical assumption they'd learned. They were being cautious now. Captain Whitaker's voice came over the intercom, carefully controlled. "Harlan, what are you doing?" "Testing a sight modification, sir." "What modification?" "Custom sight grid, for extreme range ballistic calculation." Silence for 3 seconds. Then, "Did engineering approve this?" "No, sir." More silence. Harlan could imagine the conversation in the cockpit. The pilot and co-pilot debating whether to order the modification removed, whether to report Harlan for violating regulations, whether court-martial charges were warranted for unauthorized fire control modifications. But before Whitaker could respond, the ball turret gunner's voice cut through. "Fighters breaking formation. 4 bandits diving. 11 o'clock high. 4 Bf-109s diving from 28,000 feet. Standard German tactic. High-altitude dive. Build speed. Attack the formation's lead. Elements." The conversation about Harlan's sight grid ended. Immediate threat took priority. The formation's top turret gunners opened fire at 1,200 yards. Tracers crisscrossed the sky. The Bf-109s split. 2 broke left, 2 broke right. They weren't committing to attack runs, just probing, testing the formation's defensive fire, looking for weak spots. The 6 Fu-190s that had been orbiting at 3,000 yards began descending, moving into attack position. They'd been waiting for this, waiting for the Bf-109s to draw defensive fire and attention. Now, they'd attack while formation gunners were focused elsewhere. Harlan tracked the descending Fu-190s through his sight grid. 2,200 yards. Closing, still beyond normal engagement range by doctrine. But within his grid's calculated parameters, he'd missed his first 2 shots. Missed by not accounting for orbital geometry. But he'd learned, adjusted, understood the compensation, required now. The lead Fu-190 leveled out at 20,000 feet, 5,000 feet below the B-17 formation. It began a climbing attack, run toward the formation's tail element. Standard approach. Climb from below. Attack the most vulnerable bombers, the ones with damaged engines, the ones falling behind. Defiant wasn't in the tail element. Not yet. But they were falling behind steadily. 3 engines couldn't maintain formation speed. In another 10 minutes, they'd be completely separated, completely vulnerable. The full of 190 climbed through 18,000 feet, range 1,900 yards, not orbiting now, straight climbing attack, linear geometry. The mathematics Harlan knew from railroad work, the calculations he'd practiced for 3 years. He tracked the fighter through the grid. The fighter was climbing at approximately 20 degrees. Speed roughly 350 miles per hour in the climb. Range 1,900 yards. Flight time for 50 caliber. Rounds 2.2 seconds. Required lead. Approximately 4.5 aircraft lengths ahead of current position. Elevation correction. Aim point 30 feet above the fighter's current altitude. His hands moved the gun mount smoothly. Tracked ahead of the fighter. Elevated slightly. The fighter crossed into his calculated aim point. The intersection of range, line and lead marker on his grid overlay. He pressed the trigger. 5-round burst. The 50s hammered. Tracers arced away. Harlan watched them climb, watched them drop according to calculated trajectory, watched them travel 1,900 yards in 2.2 seconds. The Fevu 190 flew directly into the stream. 3 rounds connected. 50 caliber impacts along the fighter's right wing root and engine cowling. At 1,900 yards, Harlan couldn't see detailed damage, but he saw the result. Dark smoke began trailing from the engine. The fighter's climb angle decreased. The pilot rolled left, dove away, toward lower altitude. Breaking off the attack run. Harlan had just scored a confirmed hit at 1,900 yards. The intercom exploded with voices. Waist got a hit. Did you see that? 2,000 yards. The 190's smoking. How the hell did he hit at that range? Morrison's voice cut through the chatter. Harlan, what the hell was that? Sight grid, Harlan said. Calculated lead for extreme range based on ballistic trajectory mathematics. Whitaker's voice came next. Slower. More controlled. You're telling me you installed an unauthorized fire control modification on my aircraft? Yes, sir. And you didn't inform me or your crew chief? Correct, sir. Silence for 5 seconds. Harlan waited. The penalty for unauthorized modifications was court-martial. Possible dishonorable discharge. He'd known the risks when he built the grid. Known the consequences if command found out before he could prove it worked. But he'd proven it worked. 1 confirmed hit at 1,900 yards. Damaged or destroyed. 1 German fighter using calculated mathematics that doctrine said was impossible. Finally, Whitaker spoke. Does it work consistently, or was that luck? Should work consistently, sir. Based on ballistic calculations and surveying trajectory mathematics, the geometry is sound if the gunner can calculate properly. Another pause. Whitaker weighing options. Regulations versus results. Court-martial charges versus tactical advantage that might save lives. Can you hit the others? Yes, sir. If they come within 2,200 yards on predictable flight paths. Then do it. We'll discuss regulations after we get home. If we get home. The 5 remaining FALV 190s had seen their leader take damage, seen tracers reaching out from a B-17 at ranges they'd thought were safe. They adjusted tactics immediately. Stayed at 2,500 yards, outside Harlan's calculated grid range, outside any American gunner's range by established doctrine, but they still had a job. Their mission was disrupting bomber formations, shooting down stragglers. They couldn't accomplish that from 2,500 yards. Eventually they'd have to close. Eventually they'd enter Harlan's calculated engagement envelope. At 10:03, number 3 engine's vibrations suddenly worsened. The feathered prop began windmilling despite the feather position. Something had failed in the feathering mechanism. The windmilling prop created massive drag. Defiant speed dropped to 142 miles per hour. Whitaker made the decision immediately. We can't maintain formation. Falling back before the prop comes apart and takes the wing with it. Defiant dropped back. Fell away from the formation's protective envelope. The main bomber stream continued toward Schweinfurt at 180 miles per hour. Defiant struggled at 142. The gap opened at 38 miles per hour. Simple mathematics. In 5 minutes, the formation would be 3 miles ahead. In 10 minutes, completely out of sight. The crew understood what this meant. Every man aboard knew the statistics. 62% of isolated bombers never made it home. Average survival time: 11 minutes from separation to destruction. The 5 FW-190s saw it happen. Saw an isolated B-17 struggling on 3 engines with a windmilling prop. Saw exactly the target they'd been waiting for. They stopped orbiting at 2,500 yards, started closing, not rushing, moving methodically. Professional. They had time. They could coordinate their attack, choose their vectors. At 10:08, 6 more fighters appeared from the north. Bf-109s. Fresh aircraft with full ammunition and fuel. The Germans were committing serious resources to this isolated bomber. 11 fighters total against 1 B-17. The fighters formed up at 2,500 yards, coordinating, planning. Then, at 10:12, 7 of them began their approach. 190s. 3 Bf-109s. The others stayed at altitude as top cover. The attacking fighters split into 3 groups. 3 approaching from 6 o'clock high, 2 from 6 o'clock level, 2 from 5 o'clock low. Coordinated multi-axis assault. Exactly the tactic that killed isolated bombers in 11 minutes. Whitaker's voice came over the intercom, calm despite the circumstances. All gunners. We're about to get hit from multiple directions. Pick your targets. Make your rounds count. If we survive the next 5 minutes, we might make it home. He paused. Then added, Harlan, I'm moving you to tail position. That's where they'll concentrate their attack. Patterson, swap with Harlan. The tail gunner, Sergeant Mike Patterson, was a solid gunner. 49 missions, good with the standard ring-and-bead sight at 600 yards. But he'd been trained on doctrine that said extreme-range shooting was ammunition waste. Harlan unplugged his oxygen line, unplugged his heated suit connection. Started moving aft through the bomber, through the radio compartment, through the waist section, into the narrow tail cone, the loneliest position on a B-17. Most tail gunners died there, trapped when fighters soared through the fuselage, or frozen when heating failed, or killed instantly by 20mm cannon fire. But the tail position had the best field of fire for stern attacks. And stern attacks were coming. Harlan squeezed into the cramped compartment. Patterson helped him settle in behind the twin 50s. The space was barely wide enough for one man. The guns dominated everything. Small windows on either side. Tail glazing in back giving clear view astern. He plugged in oxygen. Plugged in heated suit. The temperature at 25,000 feet was -40 degrees. The heating system couldn't keep up. His breath frosted inside the oxygen mask. His fingers were already going numb despite the heated gloves. He settled his hands on the gun grips. The sight grid was directly in his line of sight. Grid lines, range markers, calculated lead points. 3 nights of construction, 18 months watching the doctrine fail. All of it coming down to the next 5 minutes. Through the tail glazing, he could see 11 German fighters at 2,500 yards, forming up, coordinating. 7 were breaking away, starting their approach. Range 2,200 yards and closing. Harlan checked his ammunition. 4,000 rounds total in the tail position, 2,000 per gun. He'd fired 35 rounds from the waist position. The tail guns were fully loaded. The fighters closed to 2,000 yards, then 1,900. The mathematics was clear now. Flight times, drop rates, required leads. Everything he'd calculated on paper would be tested in combat in the next minutes. His hands were steady on the grips. His breathing was controlled despite the adrenaline. His eye tracked through the sight grid, range lines, lead points, the geometry of survival measured in plexiglass and piano wire. The fighters reached 1,800 yards, committed to their attack runs. And Harlan's finger moved to the trigger. The fighters closed to 1,600 yards. Harlan fired. 8-round burst. 4 hits across the lead Bf-109's engine cowling. The fighter shuddered. Rolled away, trailing smoke. Second confirmed kill. He immediately tracked the second fighter. 1,500 yards. Fired again. 6 hits. The fighter exploded. Pieces tumbled through the air. The high group dove. Morrison in the top turret engaged at 1,200 yards per doctrine, got hits on one fighter. The other two continued toward Harlan's position. 1,400 yards. Harlan tracked. Calculated deflection for diving angle. Fired. 7 hits. Fighter disintegrated. Third kill at extreme range. The remaining fighters broke off. 4 aircraft damaged or destroyed in 90 seconds. The others climbed away. Returned to base. 11. Fighters had attacked 1 isolated bomber. Lost 4 aircraft. The mathematics of that exchange violated everything German tactical doctrine assumed about American defensive fire. Defiant turned for home. Limped back to England on 3 engines. Landed at 13:47, 6 hours after takeoff, running on fumes. Colonel William Stevens met Harlan on the hard stand, examined the sight grid, listened to the combat reports. Made his decision immediately. No court-martial. Promotion instead. Harlan would train every gunner in the group. By January 1944, 340 B-17 seconds carried Harlan's sight grids. Bomber losses among isolated aircraft dropped from 62% to 31%. 500 bombers saved by February 1945. 5,000 crew members who came home. Harlan returned to Montana after the war. Resumed surveying work. Married Margaret. 3 children. Quiet life calculating railroad grades through mountains. The same, mathematics that calculated bullet trajectories. He died January 1998, aged 79. His sight grid preserved at the Air Force Museum in Dayton. Small plaque explaining how a surveyor's mathematics changed bomber defensive tactics. Not through official channels. Through a sergeant who understood that trajectories are trajectories. Whether laying railroad track or putting bullets into fighters at 2,000 yards. The mathematics doesn't care about regulations. It just works.